we will be certainly discussing in these practicals. Okay, so overall there will be I think 10, 10 practicals if this is not there, if this is not available in our lab, and if this is available in our lab, then it will be 11 practical. Okay, and coming to the general guidelines to students, you must have received these guidelines, isn't it? Have you received these guidelines in your email?
Yes, sir, we have received it.
Okay, fine, good.
Yes, sir.
So for
Yes, sir.
okay.
Yes,
So
sir.
for practical courses, lab manuals have been made available to you by through MIS by the course coordinator. Few of the files which will not be able to upload in the MIS because of the size restrictions. Okay, so you have to depend more on the Google class. On the Google class itself, I will be uploading uh, most of the video and the lecture material or the uh, lab manual. Mostly all the lab manuals are related to some or other standard, either it is BIS standard or ASTM or ISRM standard. So those standards I will be uploading in the Google class immediately after the practical. Okay, high quality video demonstrations we will try to show the best possible way of the videos that we have made. Okay, instructor may take and may assign take home assignment. Okay, and may not give you take home assignment, depends on the instructor and the kind of practical you are doing. Okay, and the most important thing is that handwritten report of individual experiments is to be submitted through email to the respective course instructor at the end of each lab session. So instead of email, I will be making a Google form. Okay, that has a facility to say that it will be accepting your what to say, the lab manuals. So by the next day, your lab manuals have to be uploaded. Handwritten individual experiments, whatever you conduct, has to be uploaded on the next working day. Okay. Anything uploaded beyond that working day will be simply ignored, right? So that's very important. Within the next day you have to submit it. Okay. Weightage distribution of practical courses will be given by the instructor. Okay, so in that minimum 2 online quizzes will be conducted, and at the end semester there will be an online mode of exam. Okay, so 2 quizzes and 1 online mode exam. So if we do the distribution, let me make the distribution here itself, and if you all agree, we will stick to it. Okay. Handwritten. This is from some other course. Some other faculty members, they are following this guideline. Okay, so we will discuss here and finalize our marking scheme. Oh, some formatting issues. Okay, anyway, formatting etc. we'll do later. So number one is your handwritten practical notebook. Few people take it as 15. Second is quiz 1 and quiz 2. That they have taken as 30. Punctuality and performance very difficult to measure in the class. So um, it is impossible to measure punctuality. Okay, we will have lab exam, and if required, do you want Veva Bose?
No, sir.
No.
No, sir.
Veva Bose करना है end में, or you want lab exam only?
Lab exam only.
Lab exam.
Okay.
Lab exam.
Okay, agreed. So, and then there has to be a total. Total is 100. Guideline क्या बोल रहा है? The course instructor will inform you about the weighted distribution of practical courses. Minimum 2 online quizzes and 1 end semester online mode is to be written. Okay, so we have to give some weightage to your weekly work. Okay, so now tell me what should be the weightage in these three.
So 30, 30, 40.
Yes, sir.
There are two quizzes, so this will be 40,
10, 40, 50. 40.
30, 40 and 30.
30.
30 इसको नहीं दे सकते ना, लैब एग्जाम एंड सेमेस्टर है ना, तो ज़्यादा रखना पड़ेगा।
50 marks का lab exam.
20, 40, 40. इसको 40 कर दीजिए, क्विज़ को 30 कर दीजिए।
Which is 15 into 2, 30 कर देते हैं। Okay.
सर हैंड रिटन जो प्रैक्टिकल नोटबुक है उसको 20 कर देते हैं, क्विज को 30 कर देते हैं, लाइव एग्जाम को 50 कर देते हैं।
This will be 20 and this is 50. Is this okay?
Sir, yes sir, this is correct.
Yes, sir.
Yes sir. हाँ सर सही है।
Handwritten practical notebooks 20, 2 quizzes 15 into 2, lab exam 50. So at the end ये हम लोग इसको evaluate कर लेंगे. Okay, so let it be specifically 15 multiplied by 2 equal to 30. Right? Agreed by all?
Yes, sir.
Right.
Yes sir.
Yes, sir.
Yes sir. Yes sir.
So I'll communicate it. I'll do few of the formatting, some of the conditions which are written here in the guideline. Okay, and then I will communicate you. In fact, yesterday night 7 o'clock, I was asked to conduct this practical. It was not in my teaching load. There were few things were there because of that. I was asked to take this class and I agreed to take this class. Okay, so anyway, we'll be doing. I'll be demonstrating you one of the practicals. I'm not fully prepared today, but anyway, that's not a very difficult task. I'll do it today. Okay, so before that, attendance is another issue for MTech. We have to take the attendance on a regular basis. Okay, so how do we take the attendance? ऑनलाइन यस सर नो सर वही कर देते हैं.
Yes, sir.
टुडे इज 17th, no?
Yes, sir.
Yes, sir.
17th. चलो ये फॉर्मेटिंग कर लेंगे, कोई दिक्कत नहीं. आदि लक्ष्मण इज इट देयर?
Present, sir. Present, sir.
Okay. And Amit Kesarwani?
Present, sir.
Amit Kumar is present.
Yes, sir.
Yes, sir.
Ankit Vignesh present.
Present, sir.
Ankit Karketa is present. Ashish Tiwari present. Ashok
Present, sir.
Kumar present. Biswajit Behra present.
Yes, sir.
Challa Kranti present. Chetan
Sir.
Mehra is present. Devashish Behra
Yes.
present.
Present, sir.
देवांशु वर्मा, ये नाम कहाँ से
Present,
आया?
sir.
अच्छा, anyway, वो देवांशु वर्मा, are you from Trust?
Yes, sir.
Okay, that's why your name is not appearing here. It will appear in the bottom. Okay, anyway, no issues. I'll call your name. Google to
Yes, sir.
Dev Singh.
No, sir. Yes, sir. Google Joshi.
Google to Dev Singh is there.
Yes, sir.
Harish Angot.
Yes, sir, present.
Okay. Harshvardhan Singh.
Present, sir.
Himanshu Piprasania. Himanshu. Not there. Okay. Jagiri Jayant. Jagiri Jayant is there? No. Absent. Jigar. Absent. Kuna Arvind.
Present, sir.
Present. Mandeep Singh Gill.
Present, sir.
Mandalik Prajwal. Absent. Mohit Kumar. Mohit Kumar is absent. Then Nitesh Kumar Rajwade. Nitesh Rajwade is absent. Nitin Anand. Nitin Anand. Absent. Pankaj Das. Present.
Yes, sir. Present.
Prashant Kumar Prajapati present.
Present, sir.
Priyansu present.
Present, sir.
Rajesh Kumar is present. Rakesh Atla present.
Present, sir. Present.
Sai Behra.
Present, sir.
Sanjeev Kushwaha, you are from Trust?
Present, sir.
No, I'm asking you, are you from Trust?
Yes, sir.
Okay, your name will appear in the bottom. Call again. Then Satyabrat Naik is present. Saurabh Kumar
Yes, sir.
present.
Present, sir.
Subham Patel present. Subham Siddharth Urmilia. Siddharth Urmilia. Some name yesterday I got from MIS. किसका नाम था? Attendance was not, and email was not there, and I think that is an addition to this list. Saurav Kumar, is he there?
Yes, sir.
सौरभ, ये कंप्यूटेशनल जियोमैकेनिक्स का अटेंडेंस में योर नेम इज देयर?
Yes, sir.
डिड आई टेक योर अटेंडेंस ऑन दैट डे? हाँ, आवाज नहीं आ रहा सौरभ।
सर इसमें नहीं है, इसमें
ये नया नाम दिखा मुझे। क्या कितना रोल नंबर है सौरभ? व्हाट इज योर रोल नंबर?
73 सर, 31।
क्या? 31?
यस सर।
क्या सीरियल नंबर 31? नहीं, अरे ये कंप्यूटेशनल जियो मैकेनिक्स का क्लास अटेंड किए हो आप?
सर नहीं किया था।
हाँ, उसमें नाम नहीं था।
यस सर, वो लेट।
So are you registered in that course?
नो सर।
Okay, you are not registered in that course. Okay, fine. So there your name is not there, but in this computational geomechanics your name is there. And
Sir,
your-
we have to register there.
I don't know, this is a compulsory course. How your name is not there? How you did not register? You are an MTech student, no? You are not a PhD student.
Yes sir.
Check it with administration what happened, why your name is not appearing there.
Yes sir.
Okay, and whether you have to attend the class or not.
Sir, Jagiri Jain is present, sir.
हाँ?
Jagiri Jain.
जागरी जयंत, चलो लास्ट में अभी देखते हैं। शुभम कुमार दास, शुभम कुमार दास एब्सेंट। सिद्धार्थ कुमार उमेरिया दिखा था कहीं?
प्रेजेंट सर।
प्रेजेंट। सौरभ आनंद प्रेजेंट। सुजीत गुप्ता प्रेजेंट। वकार सिद्दीकी प्रेजेंट। योगेश बिंदल एब्सेंट। आकाश पवार I think he has not joined the class also. Whether he has joined? Akash Pawar. He has joined the class. Anyway. Akash Pawar is absent. Aman Agnihotri. Absent. Devanshu Verma. Present.
यस सर।
Then Kunal Gupta.
Yes, sir.
Kundan Kumar Rai.
Yes, sir.
Rajendra Singh.
Yes, sir.
Okay, fine. Rajat Kumar.
Present sir.
Present. Sanjeev Kushwaha.
प्रेजेंट सर।
और सोना रे। Absent. कावले वैष्णवी रमेश कावले। वैष्णवी कावले दिख तो रहा है। वैष्णवी, आर यू प्रेजेंट और स्लीपिंग?
Yes, sir.
हाँ, ओके।
So I'm present.
हाँ, ओके। वकास इम्तियाज
Yes, sir, present, sir.
present. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 आर एब्सेंट. उसमें से किसका आ रहा था?
सर हिमांशु पीपल
सर जागृति जयंत सर.
जागृति
हिमांशु
जैन
पीपल
इज
सानी.
प्रेजेंट. और हिमांशु कहाँ है?
हिमांशु पीपल सानी. यस सर.
प्रेजेंट.
हेलो.
और कोई?
सर योगेश कुमार भी सर.
Mandik Prajwal is not there. Jigar is not there. Mohit is not there. Nitesh, नितिन नहीं है. शुभम कुमार दास नहीं है. योगेश बिंदल दिख रहा है. आकाश पवार एब्सेंट. अमन अग्निहोत्री एब्सेंट. And then Sonak Ray. Rajat, please switch off your mic when you are asked to speak. Then you switch on your mic. Yogesh, please switch off your mic. Okay, so attendance is over. Now we'll look into the practical. So first practical is your determination of Atterberg limits of soil. So before we discuss the practical, I'll give you a small background. What are Atterberg limits and what is how is it defined? Especially in the presence of water that is there in the voids of any fine-grained soil can affect its engineering behavior. Okay, and therefore we need to compare or scale the water content against some standard of engineering behavior. Okay, and what is that standard of engineering behavior we'll see in the next slide. Okay, so like plasticity or the index is one parameter through which the soils having a lot of clay can be distinguished. Okay. So if you define it, it is basically the threshold water content at which certain types of engineering behavior can be expected. Okay, and for each and every soil, these water content boundaries will be different, but the referenced behavior of the soil will be more or less same. Okay, and they are very important in terms of these limits. They are very important in terms of describing the fine-grained soils. Okay, and they are used in classification of soils also. And why this is required? Because these limits or these numbers, they are basically correlating with the engineering properties and engineering behavior of the soil. Okay, few of the terms related to Atterberg limits, sometimes you will see upper limit of viscous flow, lower limit of viscous flow, liquid limit, sticky limit is somewhere used in engineering places, but very civil engineers don't use it. Okay, cohesion limit is where the grains ceases to join together to each other. Plastic limit and shrinkage limit. Okay, and these two terms, sticky limit and cohesion limits, they are basically used by ceramic engineers and agricultural scientists, whereas these mold ones they are used mostly by the civil engineers or the rock engineers or the foundation engineers. So this curve is will be showing you in one go the various limits or the Atterberg limits and how they are defined. Okay, so soil can behave like a brittle solid if there is no moisture. If you add a little moisture, it starts behaving like a semi-solid, and then as you go on increasing the water content in the soil, it also behaves like a plastic solid, and after a certain percentage of moisture it starts behaving like liquid. Okay, so this is the state line and this is the water content line in terms of the moisture percentage. Okay, so we start from the back. Okay, you have too much of water content in the soil, so it will behave like a liquid. Okay, and if you go on extracting out moisture from that soil, there will be a point at which it will start behaving like plastic. So that moisture percentage in the soil at which it changes its engineering behavior from plastic solid to liquid is known as the liquid limit, and plastic limit is the moisture percentage in the soil at which it changes its characteristic from semi-solid to plastic. Okay, and brittle solid, just like rocks, very brittle. If you try to load it, it will show a stress strain curve, but there will be no post peak failure behaviors, so it will crush immediately. So when moisture is very less, it behaves like a brittle solid. So the percentage of moisture in the solid soil at which its behavior changes from brittle solid to semi-solid is known as the shrinkage limit. Okay, and accordingly liquidity index has been defined. Okay, and in few books you will see that it is PA minus WN, and what LI is liquidity index and it is defined as WN minus PL by PI. Now what is WN? WN is the natural water content which you take out from the field. Okay, minus the plastic limit. Plastic limit is basically the PL, plastic limit that you determine the moisture content in the laboratory, after which the behavior changes from semi-solid to plastic. Okay, and plasticity index is nothing but it's the difference in the moisture percentage of liquid limit and plastic limit. So liquid limit will have more moisture, plastic will have less moisture. So LL minus PL is PI. So this index is also used by the civil engineers to classify the solids according to liquidity index. So if the liquidity index is less than 0, then the soil is in brittle state, and for semi-solid it is liquidity index is 0. Okay, and liquidity index varies from 0 to 1 between plastic limit and liquid limit, and liquidity index is more than 1 when it is in the liquid stage. Now coming to the engineering behavior of the soil, if you plot the stress strain curve of a brittle solid, it will go on taking a load, and this is the shear stress by shear strain curve. Okay, so here either it can behave like a brittle solid or a semi-solid, and there will be no peak behavior. There will be a peak behavior. After that, post peak behavior, it will not show any curve. Okay, so that is the case when the soil behaves like a brittle solid or a semi-solid in terms of its stress and strain curve. Okay, and if the water content in the soil is more, okay, so up to the plastic limit or near to this plastic limit, beyond the plastic limit, it will show some sort of post failure characteristic. But the moment you increase the water beyond liquid limit, it will somewhere near liquid limit. Okay, so it will not show any failure curve. It will, as you go on increasing the shear stress on the soil, the shear deformation will also go on increasing. This behavior you will see somewhere near the liquid limit. And once it starts behaving like a liquid cannot sustain shear stress. So you will not be able to draw any curve of shear stress versus shear strain when the water content is more than the liquid limit. Okay, so when you have to design any foundation or any structure on soil material, what is going to be the percentage of moisture in that soil before the rain and after the rain, and how the foundation should be designed, that will depend upon the stress strain characteristic of the soil. Okay, and after rain, if it is going to form a liquid like structure, water is not draining out from your foundation, then this is a very dangerous thing. And even after the rain, if the water is drained out, but it is in between plastic limit and liquid limit, so your structure load has to be designed in such a way that it is at least somewhere below the failure limits. Okay, so this kind of engineering behaviors can be studied for soils, and this is how the soils can be classified with respect to the liquid limit, plastic limit, and shrinkage. Shrinkage limit I will explain you after some time. Okay. Okay, coming to this liquid limit, so when it starts behaving like a liquid, okay, it behaves like a non-Newtonian liquid. Perfect Newtonian liquid will have shear velocity gradient versus yield as a straight line. Okay, real plastic material will have more flow, and ideal plastic will have this curve. You must have studied in your fluid dynamics. Okay, coming to the shrinkage limit. Now this is determined as the shrinkage limit, that is from semi-solid to brittle solid. Okay, so how do we define the shrinkage limit? Okay, so shrinkage limit, before we discuss these definitions, See, soil is made of, if you see the phases, three phases of material are available in soil. One is solid phase, you get some moisture as water, and sometimes when the soil is not fully saturated, it will contain air also, right? So if you take out a lump of soil which is dry, and if you heat it in the oven, then also it will lose some weight, okay, by expansion of water. Minimum moisture will be there, right? So that means soil has these three phases. These voids will contain the air as well as water also, and it has a solid matrix known as solid, right? So if soil is saturated too much, and if it is in the liquid state, then there are no voids available in that soil, because all the voids are filled with the water. Now it will have a certain volume at this water content. Now if you start drying this soil, what will happen? There is no air, only water is being expelled out from that soil, so its volume will reduce. So as you go on reducing the moisture from a liquid state soil, its volume also starts decreasing. And here they are plotting these things, total volume of soil mass. So total volume of soil is basically the volume of air plus volume of voids plus volume of solids. Now as you go on reducing the water content, when it reaches a plastic limit, then also the volume has reduced. Beyond plastic limit up to the solid limit, the volume will go on reducing, and there will be a limit of moisture. Even if you extract water from that solid, from that soil, its volume will not change. So this is the point, that is point, or this is the point, this is the volume at which the soil is not shrinking, is known as the shrinkage limit. Now coming to the definition, shrinkage limit is defined as the maximum water content at which a reduction in water content will not cause a decrease in the volume of the soil mass. Or in other words, a soil can be completely saturated. It is the lowest water content at which the soil can still be completely saturated. Okay. So this is how the shrinkage limit is defined. Okay. Plasticity का कुछ theories है, let us leave it. So we will be.
कलर तो चेंज होगा
क्या?
कलर तो चेंज होगा सॉइल का.
कलर, हाँ या कलर will change. कलर will change.
वॉल्यूम चेंज नहीं होगा, कलर हो जाएगा चेंज.
मेरा माइक स्लो है क्या? Speaker sound is less. Yeah, please speak again.
वाटर कंटेंट कम करने से वॉल्यूम चेंज नहीं होगा सॉइल का कलर तो चेंज हो जाएगा सर.
कलर तो यहाँ से भी चेंज होना चालू हो जाएगा, यहाँ भी दिखने लगेगा आपको.
सेमी सॉलिड स्टेट.
हाँ. प्लास्टिक स्टेट से ड्राई होना चालू होगा ना, तो कलर चेंज होना चालू हो जाता है. ओके. हाँ, right. Now these three limits what we have seen is the liquid limit, plastic limit, and shrinkage limit. So we will discuss about the liquid limit, plastic limit, here, and shrinkage limit का मैं वीडियो नहीं बना पाया हूँ. Okay, but I will share a link of the shrinkage limit video. Okay, you can go through that. Yeah, coming to this method for determination of liquid limit. There are two methods. The first method is known as the Casagrande method, and another method is known as the Cohn-Penetro method. Okay, for determination of liquid limit. And for plasticity limit, we have another method. Shrinkage limit के लिए you have to use lot of things and mercury and etc. Mercury is again a hazardous material, so we did not do it in our lab. In fact, I got a video. I will upload that video. Okay, how the shrinkage limit is determined. So these determinations are basically based on whatever the theory we have discussed. Okay, so coming to the liquid limit by Casagrande method, it's a very simple experiment. Okay, there is a cam. Okay, so this cam will rotate on an axis. Okay, so at this point from the center, from the pivot, this is the maximum distance, and this from this pivot to this point, the distance is the minimum distance, right? So as it rotates anti-clockwise, it will go on lifting this lever. Okay, this lever will be lifted. So when it lifts the lever, this cup will also lift up. Okay, and when this rotation has come to a point, this point, it comes to another point, what will happen? It will drop suddenly. Okay, so this complete cup will drop. Okay, the cup looks something like this. I'll show you the video also. Okay, and there is a pad over this. Okay, and few specifications as per the IS code are given here. So before we discuss more into this, let me take you to the video so that will clear your concepts of Casagrande part 1. Okay, so for conducting this experiment, you need soil, water, weighing balance, dish, watch glass for measuring the moisture content. And this is how the Casagrande equipment looks like. Okay, this is its bowl. Here we have a motor, and we will see more detail in the video how the cam looks. And this is your grooving tool. Okay, these are your watch glass, right? So this specification of this grooving tool is given here. Okay, it is 2 mm here. This distance has to be 8 mm minimum, 11 mm wide. Okay, and in this bowl, the bowl which you see here, its section is shown in the figure. You will place a soil pat into this, and then on this soil pat you will try to make a groove. So at the bottom, this soil will have 2 mm width, and at the top it will have 11 mm width. And the soil which you have to use for this experiment should be minus 425 micron on IS sieve. Okay, and then it is kneaded with water and place in the cup equipment, and then groove it using the grooving tool. Okay, and this thing is rotated at a rate of 2 revolutions per second, which will apply blows to the grooved soil. Okay, So now let me run the video again. Okay, so this is your grooving tool. Yes, in few of the equipment there is handle also with which you can do. This is the counter. You can reset the number of revolution counter, number of drops counter. So you see he is rotating with hand and this counter is moving and this is counting how many blows are being taken up. Now you see this is the cam which I was showing you. Okay. See the rotation. या ये देखो फिर से ये ऊपर उठा जैसे ही यहाँ टच होता है this will drop. Okay, that's the function of the cam. Okay, and then you can measure the number of blows through this counter, or you can count it manually. This counter is not functioning properly, so at the time of experiment we counted it. Okay, and the rate of rotation has also to be 2 revolutions per second. Okay. How much is written? 2 revolutions per second. Okay. Now coming to the soil part. So they are mixing the soil and water. You mix soil and water up to a certain percentage. Okay, again how much water is to be mixed, that again depends upon your experience. Why I am telling you that you will come to know once you see the graph. Okay. So they have prepared this soil. Okay. Then they will place it in the bowl. Right. Then it has to be placed properly. Tap it properly into the bowl.
कहीं ऐसा ना हो कि फिसल जाए बॉडी से, बॉडी पे दबे हो ना अच्छा से.
Okay. Okay, now they are trying to make the groove into the soil pad. Okay, so bottom में 2 है, ऊपर में 11 है. Okay, now what they do is, so this is what you see in the groove in your picture. Okay, it is 11 mm. So what the experiment desires is that a 12 mm length of this soil pad is to be, when you tap the bowl, this soil will flow towards the groove and it will try to close the groove. Okay. So when at least about half an inch of the soil pad is closed, that at how many blows this is closing, that number you have to note down, and then you have to note down the moisture percentage. Okay, so now they will tap it on the rubber base. They will start it, and you have to note down the number of taps. Okay. Okay, number of tabs. See here the groove is closing. Minimum 1 inch has to close, but here everything has closed. Okay, so number of blows they have counted, and the grooves at how many numbers the groove has closed they have counted, and then that same soil is taken onto a watch glass. So before taking it on the watch glass, you measure its weight of the watch glass. Then you place this soil, little bit of soil, so that you can determine its moisture content. So weight of watch glass plus weight of soil is 43.5 gram. Right. This completes one set of the, so 13 blows, and this is how you will note down the number. Serial number 1, first experiment, weight of the watch glass plus soil, and then you send this watch glass for drying into an oven, and then you find out its weight. So with this data, will you be able to find out what is the percentage of moisture?
Yes, sir.
Yeah.
Yes, sir.
So that is what is being done. Okay, so here you will be now sending that material into the oven. Okay, so like that 4 or 5 set of experiments are conducted, okay, at different moisture contents. Okay, so he is making it a bit harder this time. Okay, उस समय काफ़ी वाटर था, अभी थोड़ा सा वाटर कम किया इन्होंने. Okay, and then they are fixing it. Okay, groove बनाया, then they run it, count the number of blows, and then again take that for determination, some soil for determination of moisture content. Okay, so at 25 blows it is giving 43.6 gram. So this way you note down the data. Okay, कुछ और experiments कर लिए. Okay, that way they do it a number of times. Okay, अभी तक 3 और 5 तक लेके गए हैं. 5 points they have taken, and for all these 5s the number of blows have been measured. Now all these things are being taken to the oven for drying. You keep it in the oven for 24 hours at 100 to 105 degrees Celsius. Okay. And then you next switch on the oven. Next day when you come back, you can take out the dish, and then you can find its moisture content. Okay.
5 लिमिट तक क्यों लेके गए हैं उसको? 5 रीडिंग क्यों लिए? हमारी एक्सेप्टेबल लिमिट तो 25 ब्लोज होती है.
हाँ, 25 blows होती है.
तो सर हमने 5 क्यों लिए?
5 हम इसलिए लिए कि आपको तो मॉइस्चर कंटेंट तो रैंडमली सेलेक्ट करना है ना. आपको तो मालूम नहीं है कि किस मॉइस्चर कंटेंट से वो लिक्विड की तरफ फ्लो करेगा. अभी इस वीडियो में एक के आसपास 25 ब्लोज दिखा था.
यस सर.
किसका बैकग्राउंड में नॉइस तुम्हारा और भी है क्या? रजत, बैकग्राउंड में नॉइस है क्या? ओके. हाँ, राइट. सो यू डोंट नो कि 25 ब्लोस पे ही ये हमारा कितना मॉइस्चर कंटेंट होगा. अगर if you are fortunate enough to get 25 blows, then you don't need all these 4 or 5 data. Basically, the water content versus number of blows on a semi-log scale.
Flow curve.
Is a linear curve, right? So you need at least 3 points to have a straight line. 5
Yes, sir.
minimum 5 इसलिए बोला जाता है so that you can draw a regression line. Okay, so 4 or 5 लेते हैं, right? And from that curve, all these see here they have shown 4 points. So from these 4 points you draw a regression curve, and then from this graph corresponding to 25 blows, what is the water content, that can be found out, and that is termed as the liquid limit. Okay, so whether it is IS or ASTM, they both define it as 25 blows for a 12 mm groove closure in 25 blows. What is the moisture content, that has to be found out. Okay, let me show you an Excel chart of the liquid limit. I have made it. Casagranде experiment. ओके, डेटा इसमें हम लोगों ने 5 सैंपल लिया था इसी का. ओके, that I have to delete it. I should have shown you this point also. Okay, so this was basically coming out as an outlier and it was lying away from the line. That is why we need 4 or 5 things. So you can remove the outliers also. Okay. For experiment 1, number of blows you have counted out. What this weight of watch glass was determined. Water watch glass plus soil pipe was noted. Okay, and after drying it was 41 grams. So weight of wet soil, it should be D minus C, 11.1 gram. Okay, and E minus C is the weight of dry soil. Okay, and percentage is 1 minus this fraction will give you 22% moisture. So at 22% moisture it was 13 blows. Okay, and this is how you get those data. So you are drawing a graph of moisture percentage versus number of blows. Okay, and then from that you will be either you can use the equation of that or you can use the graph to find out what is the at 25 blows what is the moisture percentage. Okay, so here it was coming as 21%. Okay, so this is how you determine the liquid limit using a Casagrande equipment. Another method is known as the Cohen-Penitro method. Okay, so here it uses this kind of pointed needle, and it has an specification again dictated by the IS code. The total weight of this plunger with all its component, so not the weight, mass should be 80 grams. Okay, and this is the cup in which soil with different moisture percentages will be kept. And of course there is a standard again in the IS which dictates its dimension, the dimensions of this cone. Okay, it has to be according to this dimensions. Okay, and here again about 150 gram of minus 420 micron thing is soil is sealed, and then it is kneaded, and then we allow to penetrate into the soil freely, and then we measure the distance, how much it has penetrated into the soil through this scale, and then penetration versus moisture graph is drawn. Okay, water content on y-axis and cone penetration on x-axis is prepared, and best fitting line is drawn. Okay, and again, as per the IS code, for cone penetrometer method, the moisture content corresponding to cone penetration of 20 mm is taken as the liquid limit of the soil. Right, let me show you the video how they do it. Cone penetrometer part 1. Okay, so this is how it looks. You can lock this at 0. Okay, you can lock the movement of the needle. Okay, and this is the measurement scale. Okay, and this point of the needle is just onto the at the level of this top level of this cup. Okay, and if it is not at this top level, then from the back side there is a needle, you have to adjust it, and then you have to set it accordingly. Okay, so this is how the simple instrument. Okay, how it's falling down, they are showing it here. Okay, you loosen it, you have to hold it properly at the soil level, and then you have to allow it to drop. Right, so let us see how this experiment they are doing. See, this is the level, scale रख दिया तो उसी 0 पे दिख रहा था. Here again soil with different moisture percentages are needed. Okay, they need this soil, and then they place it into the, again for placing this soil it has to be done in 3 stages. 1/3 has to be put into the cup, and then again tapped this way so 3 times you have to tap it, and then you have to peel off the excess sample using a straight edge or a knife. So they have placed it over the soil. Okay, just it has to touch, and this reference pin they have moved it to 0. Okay, see how the reference, just observe how the reference pin is set. See this. हाँ, ये देखो आप रेफरेंस पिन को ये आप कैसे एडजस्ट कर सकते हो. पॉइंट के ऊपर लेकर आए सॉइल के पास, एंड देन ये उठाकर ऊपर ले गए और जीरो के पास ले जाकर इसको प्लंजर के साथ टाइट कर दिया. ओके, नाउ दे हैव टाइटेंड इट. सो दिस पॉइंटर इज जस्ट टचिंग द सॉइल and then they leave it. So you have to take the reading after 5 seconds. Okay. So here it has moved somewhere around 10 mm or so. So that is noted down, and then you take out the soil from that cup and then you send it for determination of moisture content. वेरी इजी मेथड. ग्लास वॉश ग्लास लो, उसका वजन लो, उसके ऊपर सॉइल रखो, वेट सॉइल, मेजर द वेट ऑफ बोथ ऑफ द थिंग्स, देन ड्राई इट एंड देन टेक द वेट ऑफ द ड्राई सॉइल एंड फाइंड आउट द मॉइस्चर कंटेंट. ओके, सो दिस प्रोसीजर is repeated again here in this experiment at least 5 times or 4 times. Okay, at a different moisture percentages. Okay, so they are doing it. sheet कहीं है क्या वीडियो में? सेकेंड एक्सपेरिमेंट. ओके, यहाँ शीट वीडियो में नहीं आया है. एनीवे, ओके, सो ये थोड़ा और गीला करके इन्होंने किया है. ओके, हाँ, ये okay, so here they have connected it for 4 times only. Okay, and this is how they measure the weight of the soil and the penetrations were measured. Okay, so again here 15 to 25 सेंटीमीटर का पेनिट्रेशन हो नीडल में, इस तरह से आपको वो मॉइस्चर का परसेंटेज वेरी करना है. एंड नाउ व्हेन यू वांट टू vary this percentage of moisture in the soil, you need again experience. So this was based on the experience of our people, so that they could vary the penetration from 10 to 23 mm with different moisture content. Okay, और कैसा ग्रैंडे में इन्होंने एटलीस्ट 13 से 40 तक के लिए वेरी कराया था. Now see, in the last experiment someone was telling 25 blows के लिए होना चाहिए. So here you were fortunate to get 25 blows. Okay, but when you draw the regression line, you are doing it from 5. So 25 अगर उस regression line से दूर है वो पॉइंट, तब तो इस मॉइस्चर का कंटेंट पे लेना बेटर नहीं है. सो इट इज़ बेटर टू टेक इट थ्रू द रिग्रेशन लाइन. ओके, सो दैट इज़ अनदर रीज़न व्हाई वी गो फॉर at least more than 3 specimens to get a straight line. Okay, so for penetrometer, this is the reading that we have got. Okay, and this has to be a normal scale, no log scale. Penetration on x-axis, moisture percentage on y-axis, and then you get a equation. See how much they are deviating from here. Okay, but then you have to use the regression line, and this error could be because of error in the measurement of penetration or the percentage determination of moisture in the soil, but more or less it is fitting a straight line with coefficient of determination of 91%, so acceptable. Okay, so based on your data of this dry and wet soil and the watch glass etc., your moisture percentage has turned out to be 17%, 16, 18, 21, 22, and penetrations have been this. So plot a graph, XY graph. Okay, so what the standard says, for a 20 mm penetration, what is the moisture content, that we need to know. So from this Excel, we go back from here in this graph. So at this 20%, this we start drawing a line from here, and it intersects the regression line at this point, and from here again we go straight on the left. So it lies between 19 and 20. Okay, quite difficult sometimes. If you have a graph paper, at least you will get something like 19.2. Okay, or else you can use this equation. Okay, this is the regression equation. So x is your 20. So 0.25 into 20 plus 14.99. Y is giving me directly the value of moisture. So here I have calculated it in the Excel. 0.25 into 20 plus 14.22. So if you see here in this figure, it is 0.25 into 20 plus 14.22. It is giving me 19.22%. Yeah. Liquid limit. Okay. One index that is important, that is known as the flow index. Okay. IP. Is it that? Flow index has been calculated here. Let me show you the IS code that describes. I will be uploading all this material. Today's complete video I will be uploading, and then I will be uploading this IS code and this Excel. So this is basically not an Excel, it is made in LibreOffice. Okay, I don't use Microsoft Office, I use LibreOffice. Okay. So this file is in the format of ODS, Open Document Sheet. So if you are using Windows, then you have to right click and then you say open it with Microsoft Excel, then only it will open. And if you have the latest version of MS Excel, then it will open directly. Okay, so this file I will be sharing. This PDF of some lecture background that I will also be uploading. Okay, so coming to IF, what is IF flow index? IS defines it like it's available on the internet freely, this code. IF is defined as the flow index IF, and it is basically W1 minus W2 divided by log of N2 by N1 with a base 10. Okay, and what is W1, W2? W1 is the moisture content percentage corresponding to N1 drops, and W2 is the moisture content in percentage corresponding to N2 drops. Now what are N1 and N2? It is 10 and 100. The flow curve plotted on semi-logarithmic graph shall be extended at either end so as to intersect the ordinates corresponding to 10 and 100 drops. Okay, and then the slope of the line expressed as a difference in water content in 10 drops and 100 drops will be reported as flow index. So that is again calculated here. So water content at 10 drops, you can use this equation. Okay, number of blows 10, x is y is 10. Okay, and so what should be x? That can be found out, okay, from this curve. So that water content shows 23. Okay, it has to be reported as to the nearest integer. So 23, here it is 14, nearest integer is 14. Okay, and this 10 drop has been calculated like this: 255.48 minus 10. For 10 drops it is 10. Okay, and this has come this side, minus 10.83x, so it has to be divided by 10.83, that turns out to be 23, and this is 14. Okay, and IF is calculated as W1 minus W2 by log of W1 by W2, N1 by N2, N1 by N2 of base 10. So the flow constant turns out to be 9. Okay, so this is again a parameter flow index that have been used by civil engineers to classify your soil. Okay, so that is your liquid limit. Now coming to the plastic limit, time hai with. How do you measure the plastic limit? That's a very easy experiment. So what you do is you start making soil threads by rolling them on a glass plate of 3 mm such that this soil thread becomes 3 mm thick. Okay, and then you knead the soil or add water to the soil in such a way that when the moisture content at which the soil thread starts crumbling or starts breaking, that is termed as the plastic limit. Okay, so it is written here: the minimum water content at which a soil just begins to crumble when it is rolled into a thread of approximately 3 mm in diameter. When this plastic limit is reached, where thread is cracking and cannot be re-rolled to 3 mm diameter, then you collect this sample of at least 6 gram and measure its content. Okay, so that will determine, that water percentage will determine the plastic limit. Let me show the video to you. Plastic limit. Okay, they're mixing the soil. Then they make round balls out of this soil. They take small piece. The more the experiment you do, you become more conversant to this, and you know how much water is required. It is just like an art. Your mother knows how much water is to be added to the flour to make good chapatis. Okay, and if you are a beginner, your atta can be very wet. Okay, so this is their experience through which they are doing. Okay, now they have tried to roll it like a thread. Okay, now this another fellow with his clean hand, he is trying to roll it. Okay, and he is trying to roll it up to so that it becomes 3 mm. Okay, so different moisture can be maintained by adding additional soil dust. Okay, so one thing here is you see some cracks started appearing. Cracks have started appearing. Okay, so this is the moisture percentage. See, it's showing the signs of breakage. Okay, not very smooth. And then you have to again see whether it is 3 mm or not. Okay, 3 mm के आसपास है. Make it 3%. 3 mm. And see, there is a break also. Okay, so it is breaking. So this is the moisture percentage that can be termed as the plastic limit. Okay, then you take the soil sample, take its weight, determine its moisture content, and report it as a plastic limit. Okay, so these things, today's video I will be uploading, IS code I will be uploading, Excel, PDF. If you have any queries or any doubts, I'm here to explain, or else we call it a day.
Sir, I have a question that we will have to maintain the notebook, practical lab notebook.
It's better if you maintain a practical notebook. At least all the things will be there in one place. Okay, and in future you can refer it whenever you are going to your field or industry or research institutes. Okay, so that way it will be better for you, or else I don't have any objection if you write it on white paper also. Okay, but
We will have to submit it to you, sir, like we were doing during the meeting that we are maintaining
by the next day it has to be submitted. That means I will set it in Google. You start writing it. I will set it in a गूगल क्या बोलते हैं उसको, गूगल फॉर्म बोलते हैं.
यस सर, गूगल फॉर्म एंड गूगल क्लासरूम है.
हाँ, तो गूगल फॉर्म बना देंगे, उसमें फाइल अपलोड करने का ऑप्शन दे देंगे और टाइम लिमिट दे देंगे बाय टुमारो बाय 12 PM नहीं 11:59 PM.
तो सर कल तक मतलब सबमिट करना है क्या?
हाँ, एज पर द ये क्या बोलते हैं गाइडलाइन, ये तो वही बोल रहा है, गाइडलाइन कहा गया।
सर कहाँ से लिखना है, क्या लिखना है?
इतना चीज बता दिए, रामायण बक
अभी
दिए और सीता किसकी बेटी थी पूछ रहे हो जी। IAS कोड दे दे रहा हूँ मैं, वीडियो दे दिया है, एक्सेल दे दिया है, और क्या चाहिए। और एक एक्सपेरिमेंट को लिखने के लिए आपको क्या क्या आइटम देना है। व्हाट इज द ऑब्जेक्टिव ऑफ द एक्सपेरिमेंट, व्हाट इज द ये मटेरियल्स रिक्वायर्ड, little bit of theoretical background with some graphs or equations or plots that demonstrates that you have understood the concept of today's practical. And then what is the procedure that is being followed, right? And that procedure, whatever is being followed is there in the IS code which I am sharing with you. You have to write it in your own words, and a few good pictures or photographs of the instruments that have been used. डेटा जो है वो मैं शेयर कर ही दे रहा हूँ, उसी डेटा को आपको यूज़ करना है. How to make it in the form of table and how to analyze it. Those calculations you can show, and then you calculate this IF and other things that I have shown. Other than flow index और भी कुछ पैरामीटर्स हैं जो आप थोड़ा बहुत तो पढ़ना पड़ेगा. नाउ यू आर एन एमटेक स्टूडेंट, हाथ पकड़ के तो उंगली पकड़ के सब कुछ नहीं बता सकते ना. लाइक कंसिस्टेंसी इंडेक्स is as per IS code. कंसिस्टेंसी इंडेक्स है, लिक्विडिटी इंडेक्स है, जो मैं नहीं बताया बट IS कोड में है, तो वो सब कैलकुलेशन आप दिखा सकते हो. दैट शुड बी ए पार्ट ऑफ योर ये यस यस.
ग्राफ पेपर क्या ऐड करना है, लाइन ड्रॉ करना है, लाइक उसका रिग्रेशन वाला.
यू कैन यूज माइक्रोसॉफ्ट एक्सेल. तो ग्राफ पेपर वाला तो ज़माना चला गया. अब आप लोग AI और मशीन लर्निंग से रिलेटेड चीज़ें काफ़ी पढ़ रहे हो. सो आई बी हैप्पी इफ़ यू यूज़ कंप्यूटर आउटपुट बेटर. हम तो बहुत रॉ टाइप से ग्राफ बनाए हैं. बेटर ग्राफ हो सकता है और ब्यूटीफुल ग्राफ्स बन सकते हैं. सो दैट यू कैन ड्रॉ देम and paste it onto the you can take a printout or you can paste it on a word या एक डॉक्यूमेंट पे पेस्ट कर दिए, उसको PDF के साथ कनेक्ट कंबाइन कर लिए. लॉट ऑफ वेज आर देयर, नो. हैंड रिटन नोट्स एंड another PDF, if you combine it, it becomes a single file. Those things you can do. आजकल तो IT में आप लोग तो हम लोगों से ज़्यादा तेज हो. टुडे स्टूडेंट्स आर मोर इंटेलिजेंट देन us as far as IT is concerned, है ना. And if you are not comfortable with Excel graphs, then you can use graph paper. I don't have any objection. But the thing is that as far as this subject is concerned, your understanding of the concepts and your writing skills should demonstrate that everything is understood by you properly. Your documents should speak, you should not speak.
Sir, is it required like manually handwritten, or we can make the things on Word, like also the online?
वर्ड में लिखने से क्या होता है ना, एक का कॉपी दूसरा करते जाएगा, और फिर अगर हम उसमें गूगल में हम डाल दें प्लेगरिज्म चेक, तो सबका जीरो आ जाएगा, ऑटोमेटिकली जीरो हो जाएगा सबका। प्लेगरिज्म चेक में गूगल will give you 0 marks. I will not give you. Okay, so it's better you write with your hands. Okay, write it in your words. So आप देखो, आप पढ़ते हो तो दिमाग में उतना नहीं घुसता है, जब आप करते हो तो पूरा घुसता है, और खुद से जब आप लिख रहे हो ना, तो काफ़ी चीज़ें आपके दिमाग में घुसती हैं, काफ़ी कॉन्सेप्ट्स अंदर जाएगा। So writing is a good habit, and you are always evaluated on your writing skills. So make a habit of writing with your hands.
Yes, sir.
हेलो
Yes.
सर, मैंने लेट ज्वाइन किया था सर, 2:54 के आसपास। मुझे ये टाइम टेबल में मुझे लगा कि 3 बजे से शुरू है क्लास।
Okay. फर्स्ट टाइम है, दे रहा हूँ आगे से।
सर ये सेम चीज मेरे साथ भी।
आज का लीनियंटली दे रहा हूँ, आगे से नहीं दूंगा। Yes. Is it visible? Okay, I have to make it visible. 1 minute. Visible है?
यस सर।
Jigar is there?
सर नितिन
Yes, sir.
Where is Jigar?
Yes, sir.
Jigar is there. Okay. Mandalik Prajwal absent. Mohit Kumar absent. Nitesh Rajwade absent. Nitin Anand।
यस सर। सर मैंने भी 3 बजे ज्वाइन किया सर।
अच्छा, ठीक है, कंफ्यूजन है इसमें। I think there is some confusion in the timetable. Normally,
Yes.
It is being done by the department first, and then it is communicated to the administration, and then they release the timetable. Okay, a lot of people are involved in timetable to look into the timetable classes from other departments, etc. So it's under finalization, and yesterday whatever timetable I got, I was asked at 7 p.m. to take this course. Okay, so I was also not very prepared. तो वो confusion था, and then I asked the timetable in charge to book a slot for me, and he booked that slot for me, and in my MIS I am seeing it as 2 to 4. And
सर सॉरी सर, आपने मेरा नाम आकाश।
क्या?
सर आकाश की प्रेजेंट लगा दी आपने।
आकाश कहाँ है? आकाश
पवार।
आकाश पवार। अच्छा, शुभम दास इज देयर? शुभम इज नॉट देयर। अमन अग्निहोत्री?
यस सर।
क्या कंफ्यूजन था?
यस सर, टाइमिंग का कंफ्यूजन।
अच्छा, ठीक है। सोनाक रे, where is Sonak Ray? Okay, he is absent. So 1, 2, 3, 4, 5. 5 are absent today. Okay, fine. So let us see timetable जब तक crystallize नहीं होता है, और जो मेरे MIS में है वही दिखेगा। And today again I had seen one person, no, I had shown you in the Excel. He has been added into the list of MTech. Saurabh, na?
Yes, sir.
So Saurabh, if you are a new student, then you must attend this geomechanics classes.
Yes, sir. I was unable yesterday. The late से join किया था. Activate नहीं हुआ था.
Wait. Asha, you talk to me after the class. You call me. You join in this link only. Call me and join in this link. I will add you in the geomechanics class. Okay.
Yes.
Okay. I'll do it in front of you. Otherwise, I'll forget later on.
Yes.
So it's your job to get it done. और कोई any queries, any doubts?
Sir, for submission of report, like technical report, is there any front page available from the college institution like the ITI and some other? Because you'll have to put the things there now. So there should be the front page.
No, you write it. You write your name and admission number on the page. Why to waste one precious paper?
Okay, sir.
Okay. थोड़ा सा एनवायरनमेंट का ध्यान रखो आप. कवर पेज छोड़ो भाई. एक पेज तो काम करोगे आप. बाकी जो पढ़ने वाला है वो कॉन्सेप्चुअल चीज़ों को ज़्यादा लिखो. Waqas Imtiaz, he has raised his hand. What happened, Waqas?
Sir, all the three experiments will be written in one single
Your voice is not audible. Are you using earphone? Can you remove the earphone? Your voice will be okay then. Hello. Imtiaz, your voice is not audible.
Hello.
Can you remove your earphone? If you are using earphone, please remove it. Remove. Speak a bit louder. Speak a bit louder.
Yes, sir. Am I audible now?
Tell me.
Sir, all the three experiments will be written in under single experiment, or we have to write in different, like two liquid limit experiment and one plastic limit. So we have to.
No, today's experiment is the consistency of soils, no? So consistency of the soil, liquid limit, plastic limit, etc. has to be written. And you write for liquid limit and plastic limit. यही दो चीज़ बड़े हैं. And for your knowledge, you must see the video of the shrinkage limit also. And in this PDF also the shrinkage limit is given. So try to improve your knowledge from there. And I will upload one link. I have found a very good link on shrinkage limit determination and experimental thing. That also I will share with you, that link.
Sir, main points are like, sir, first objective, then material required, and then theory is also necessary.
Yeah, a little bit of theory what I have shown in slide 9. क्या slide 9 में था कि engineering behavior कैसे change होता है. Why do you require this experiment? To understand that different moisture contents have an influence on the engineering behavior of the soil.
Yes.
Right.
Then after that, procedure, and then lastly conclusion we will conclude.
Procedure, then calculations are also there, no?
And lastly conclusion.
Procedure, then raw data, then calculations, then again different indices.
Okay.
Okay. Sonak Ray.
Hello,
Tell me.
hello, sir. Am I audible, sir?
Yes, tell me.
Sir, I was confused, sir, because the time was 3 p.m.
Okay.
Sir, and sir, I had a fever, so sir, I fell asleep, and I missed the practical and first part.
Okay, so I'll be uploading the video. You see from there. Okay, but try to attend the classes because your fellowship is awarded based on your attendance. We upload the attendance on MIS, and from there they will pick up the things, data, and Sonak Ray present. ठीक. Or
Sir, where can I find the video, sir?
on the Google Class.
Okay, sir. Sure,
It
sir.
will be all communications will be on Google Class and onto the WhatsApp.
Sure, sir.
WhatsApp पे some important things for discussion. Okay.
Okay, sir. Thank you.
And all formal materials I will upload on Google Class.
Okay, sir.
Okay. और कोई? Nitesh Rajwade, what happened? Tell me.
सर सेम प्रॉब्लम था सर 3 बजे का डेट था सर 2 बजे मुझे पढ़ नहीं पाया
Attendance मिला या नहीं?
नहीं मिल पाया
हाँ सीधा बोलो ना कि सर अटेंडेंस चाहिए. घुमा फिरा के क्यों बोलता है?
ओके
अरे एक साथ बोल दो भाई किसका किसका अटेंडेंस का क्या बार बार क्यों एक्सेल खुलवा रहे हो? नितेश राजवाड़े प्रेजेंट. और कोई है?
यस
मोहित, मंडलिक प्रज्वल, शुभम दास. हो गया फाइनल? Right. So can we call it a day? Okay.
Yes, sir.
Okay. Thank you all.
थैंक यू सर